Hey, before we start coding, I want to say this is not a tutorial. This is me simulating the type of things I do at my day job. Whenever I create some code, I would go ahead and talk with the team how my code affects whatever is existing in the project. And since I'm working on my own, I just want to share my progress and my failure-driven development of this entire thing. This is important for me to grow personally, and maybe if you are a beginner, maybe you will learn how to present whatever you're doing and embrace the failure of your own stupidity. I certainly do. I embrace that I am only a beginner in Rust, and I embrace the fact that whatever I create isn't correct. And this following video is showing that I did make stupid assumptions and I fixed them closer to the end. And I will be able to continue uh, creating something cool for me, which is decision logic, Camunda-like, uh, let's call it a system. So with that out of the way, let's continue with Rust programming, and I hope you have some fun. Hey, how are you? So I worked on my expression parsing stuff and I made it into a postfix stack. And I was kind of bragging last time that, yeah, my postfix stuff is quite robust. Um, but I didn't have tests, all right? And I implemented those, and boy oh boy was I wrong that my code is robust. So what I did is I started off with writing test for the original function I had, and yeah, I did set up the assertion stuff. So with all the opening parents and everything, I would know the amount of operands I have literally, and after I convert it to postfix, um, I would have certain amount of remaining um, items in my postfix stack, and I made it clear for myself that I do want to see these items inside there. So again, this is becoming the first item, then the next operand is in the list, the B variable, and C, right? And then we would multiply B and C together as we see it in here. Then the result of B and C multiplication will be added to A, which is clearly seen in here. And then we would have D and 2 multiplication, as we see here. And then we would subtract whatever happened. And of course, number 100 and the result of everything, it performs this operator. So this worked because this was literally the thing I was writing in the program itself when I was developing the thing. When I went into this test, this is exactly the same expression, but I don't have the parent here. And what I found that apparently I missed some sort of check in here, and I didn't have the subtract. And this is where my ego as a developer was hurt because I thought I covered all the cases. And if I go back, let me close this. if I go back over there where I convert to postfix, right? I didn't have a check over here where I would see, okay, there's a not an opening parent, but also there's not a certain operator, and in my original implementation there was just a break and the subtract just got lost. So yeah, reality check, I suck as a developer. So what next? I also found with the next check, so yeah, this worked. I also found that I didn't cover cases when there was an operator I don't cover, so I don't want to have power off operator. So power off, I just don't check, and the result of the parsing should have been error. So I'm just checking it's not okay. So this is now cemented in the code check coverage. My check for missing opening parent for a closing parent also works. In fact, if I print it out, yeah, let's do it. Let's do it like simple print out just to show. All right, where was it? So when I do cargo test with no capture flag, it should be able to show me a print line statement too. And well, you don't see. Let me move that bit down. Yep, no meshing opening parent in there. So yeah, I am returning just simple text for an error. So this is fine. What I never captured was missing closing parent for an open parent. And the way I did it for now, at least, just to have that covered, is when I finally consumed, where is it? Yep. Let me go to the back. When I finally consumed everything and there's something remaining on a stack. So the way this thing works is when you have multiple opening parents or closing parents or anything that is not pushed to postfix just yet, when we have something on a stack, when we close a so when we actually close the parents, as you could see a bit up there, right? I just drained everything to the first open parent, so that's fine. But there is a case when I just have an open parent and there's no closing parent to it, right? So this is what remains in the stack, and if I encounter it after I hydrate everything that's left on the stack, for now I check, all right, if I encounter an open parent, then none of this stuff up there worked, and this is probably an error. So I return an error with a string. So gradually I'm covering something, and whenever I decide to improve the code, well, at least this will be cemented in a test. So this is one thing that I did. I also moved the entire code into my MD logic code. I was beginning to become eager to incorporate all this expression evaluation stuff into my main program, right, where I would read some sort of a table and, you know, if you've seen the beginning of this entire stuff, let me go there. So yeah, I was gonna evaluate, like I was eager to evaluate my columns in the markdown table, but yeah, as I checked my expression, I realized that I shouldn't jump forward and should at least cover something. So this is one thing I moved, yeah, my evaluation stuff into MD logic project as a parser. It's a completely incorrect name for the folder, but at least it's there and it's covered by tests. I think the one thing that's troubling me is that maybe it's time for me to refactor a bit, because you can clearly see that when I pass stuff to my parser, I do some weird stuff in here, but technically this could be done in a parser thing. So maybe I will refactor it now. Yeah, it's a good idea. So this, I guess, is a stir, or is it? Yeah, well, let's start with the first. So I guess I need to pass the formula, not this. And you know what? Let me hide my face, because clearly you don't need to see me. And yeah, it's a stir. So this is what I'm going to have in my parser new, and I'm gonna do it here. This was like the long in the list for me. All right. So technically this, so I do some magic over here, and let's go down. Where was I passing the formula? I'm still bad at navigating in this here. So what I want to do is have this, copy, go back in there, and paste it here. No, I didn't paste it. Ah, come on. Fail fast. So select all this, yank. And here. So this will be, yeah, expression, and this should go away, and this is expression, yeah, expression. So I am passing the expression, which is a stir. I get the characters, collect them, iterate, enumerate, pickable. Whoa, it's a mouthful. Alright, so write that and go way down. Where was it? Alright, so I am passing the formula, and this entire thing is just gone, and technically this is cleaner. Let me see. Bam. There we go. Another fail fest going on. Cannot import type of a B, blah blah blah. I guess it needs char. Alright. Let's go way up to the line 15. Collect. Bam bam. No. Char. Char. I wonder if it will work. Alright. Why is it not? So apparently I don't know what I'm doing, and I will just do this. I will copy the entire thing. Line 15, go. And I will just paste. This is expression. Delete back. Expression chars. Collect. I can delete that. And this will be V. Oh yeah, there was my error. Is it it? Gee, I hope I fix it first, like fast. Oh yeah. And I need to delete that already. And I think that collect thing is also not needed. All right. So yeah, I need to pass the reference to a string now. Everywhere. So this is trash, and I would pass a formula. Also, this is trash, and I need to pass a formula, and this is trash. Formula. And this is trash, along with formula. And this is already passed in as a formula. Alright. I wonder if it will work, and if it works, then it works. Shit. Returns a value referencing data owned by the current function. So what I did is wrong. Oh yeah, oh yeah, oh yeah, oh yeah, oh yeah. So this is a variable I created here, and as soon as parser is returned, it gets destroyed. All right, let's create a expression. No, a formula reference. Formula. Of a vector. So I'm trying to make the interface cleaner on the consumer end. Okay. And I don't really care what this does. As long as my original thing is easier to maintain, self dot formula is this, and I would self can I even do that? Oh no. No. I cannot do that. Oh wait. Yeah, that's stupid because yeah. I need to do that formula is this. Oh shit. I don't know how to do this. So if I move it over here, it will not work. Shit. I didn't think this through. I did not think it through. The ownership shit just breaks me because wait. If I just do this, I will try to yank it, then I will paste it. Oh, come on. So this should go away. Expression. And there's a dot. And this is jank. Oh man. How incredibly dumb that is. So I'm back to the thing where I tried to do this collect. Let's try and do this. So this should be a vector of chars. Shit. Returns data reference owned by current function. So this is the next thing I need to work on. Well, this sucks. And don't subscribe. So yeah, I spent like 15 minutes looking at my problem, and I found out that, well, yeah, my initial thought of having a I as enumerate of slice eater of characters was incorrect. You see, in the beginning, I didn't really understand how characters work, and I made a bunch of weird assumptions that it would work. Like this, but in the end, what I actually got in my parser, which I renamed into tokenizer at this point, that I am getting a string, and I'm already able to get characters iterator from it, and I can immediately enumerate it and make it peekable to do the exact same thing I was doing. Okay. So entire creation of weird formulas vector of characters actually was redundant, so this data structure here is not needed. And yeah, I kind of trimmed down my entire code. And it compiles. The one thing that this made me do, so since this is not a vector of characters, but instead it's a characters iterator, this method now operates on a reference of a tuple. So previously, let me go to line 38. Previously, this thing, like the matcher, it was like this when I was operating on a character within the vector. So this is not correct anymore. And now it gets a reference to the tuple. So I had to change it all through the code in here, and yeah, now it works. So apparently, maybe at this point, I'm using a bit less memory. And my thing now looks a bit smaller. So I instantiate my tokenizer, which was parser. I renamed it behind the scenes. It accepts just a stir, a reference to a stir. I can parse it and convert it to postfix. Now I know this is not a well defined method, like in terms of separation of concerns. My tokenizer should not be able to convert to postfix. That should be a different object or a struct. But for now, just to cement my logic in tests at least, this works. And just as a proof of concept thing, eventually I will need, well, I do need to evaluate a program where there's just one single string inside there, right? So yeah, I made this test, succeeds single element, and the parser accepts it. It's able to parse it, and it creates a okay result, which is actually kind of cool. So yeah, I was able to remove one extra thing. Let me actually open up what I did in there. So as you see, this portion of code where I converted to chars, then I collect it into a vector, it's gone. Like this construct is gone. And when I was trying to create self formula thing before I created a parser instance, which is tokenizer now, yeah, it's gone. It's all working with the same memory instance when I convert a stir into just chars, and then immediately I skip this iter and I just work with enumerate and pickable. So entire set of instructions is just gone. So me failing at this was just great. So I'm really happy this turned out to work. There's one thing I didn't check for this test. I actually do want to cement this into a test when I create just one variable. So this is supposed to be okay, and this should be just a string. Do I have a string in there? No. So what am I doing? All right, let's delete this and make it into a string. It's going to say hello. and all of this deletes. Okay, let's see, why is there, all right, let's see, please work, shit. So my postfix, to postfix. Oh, I need to get the value of it, and how did it work in there? Yeah, I just need to unpack as a result, and it will raise an error if there was an error. So I need to unpack it with this. So if there is an OK, then the OK result will be matched to this in assertion. If this postfix is not OK type and it's an error, and then it will bubble up to this and the entire test will fail. Otherwise, we will return an OK. Good. Yes, it works. Cool. So this is a good part, like a point to finish my thing. And I'm getting really closer to where I want to be. Maybe it's almost good time to start thinking about actually evaluating this stuff, like prepare tests to run the program. But technically, before I jump into executing the program, there is something that troubles me. When I get the result, I get a number of strings on a heap within the enumerators. I would say that having a string like object in here is an overkill. I'm starting to think, maybe not in next iterations, but overall, that when I create my tokens, this variable here should be referencing the start and the end position of the original string. That way I would not create copies of strings all over the place. And I would be able to just create a slice whenever I need to from my original string, because it will always be in the memory space. So this is like a minor optimization that I'm thinking about. But yeah, the thing worked. Maybe just to make my life a bit more fun, I will think about actually evaluating the code to actually pass in A and B and C and D and see if it would return the correct number or anything else. Thank you, and if you are still here, then subscribe.